Okay, business algebra 5.3 is about annuities. Now, if you look at 5.2, the compound interest, it was about depositing a giant lump sum of money and watching it grow. However, that is not realistic for most people. So enter annuities, where you consistently make a smaller deposit in order to eventually accumulate a total. Now, the earlier deposits you make accumulate more interest, but it still, as a total, gets you potentially to a financial goal. So this formula is a little bit different. It's A equals payment times 1 plus R over N to the NT minus 1 all over R over N. This is the same formula, just solved for payment. So now let's see how this works. Given the following, find the value of the annuity at the end of the time given and determine how much is interest. Okay, so we've got the value of an annuity, and we want to determine how much is interest. So periodic deposit, $200 at the end of the month, rate 4.9% compounded monthly, time 15 years. So our payment is 200. Our rate is 0.049. And our N is 12 and T is 15 to see how this works. Okay, so my A is equal to 200 times 1 plus 0.049 over 12 to the 12 times 15 minus 1 all over the same 0.049 over 12. Now, making sure you put this in the calculator right is the hard part. So A equals 200 times parentheses 1 plus 0.049 12. Close the parentheses, use the caret to get to your exponent, 12 times 15. Close, get out of your exponent, minus 1. Close the parentheses, divided by parentheses 0.049 over 12, close parentheses. Now when you do that, you should get a value. Remember, you always round this to cents. Now let's see what it is. It looks like the amount of money you'll have is $53,013.71. Now, that's how much money you end up having. How much is interest? Well, if you let's talk about how much you paid. You pay $200 every month, so 12 times a year for 15 years. So 200 times 12 times 15 is, looks like 36,000. So if you have $53,013.71 and you pay 36,000, your interest is just the difference between them, which is $17,013.71 interest. Now again, we talk about this, $53,000 in 15 years may not be worth a whole lot more than $36,000 you paid in, but it's not quite the same as the last chapter because you're paying out the lump sum, so you can't really account for inflation, whereas some of the more recent payments for this thing were $200 like earlier this year, so it's less than 1 year since you did it. So you can't judge the amount of money quite the same way that you could before. But it does end up giving you more money overall. Now, let's do another. Given the following, find the value of the annuity at the end of the time given and determine how much is interest. Your periodic deposit is $1,250 at the end of each year. Your rate is 5.75% compounded annually. You're going to do this for 27 years. So again, we've got A equals our payment, $12.50, times parentheses, 1 plus R over N, so 0.0575 over 1, close parentheses, to the NT, which is 1 times 27 minus 1 all over 0.0575 over 1. Now again, make sure you put it into the calculator correctly. That's the most important part, but I always, of course, recommend you write this out, particularly for partial credit. It makes it easier for me. But really, where your parentheses go is a matter of understanding of the order of operations. And if you understand the order of operations, it becomes a little bit easier to understand where the parentheses are going, generally speaking. So it looks like if you do this, you've got $76,619.47. If I typed it all in right. Which again, I hope I did. I hope you guys do as well. Now again, how much is interest? You paid $1,250 a year, once a year, for 27 years. So $1,250 times 27 is $33,750. So the difference between these two is, it looks like, $42,860, wait, no, 42,800 and, okay, 42,000 something, well, it's definitely 47 cents, duh. 800, okay, so 750 minus 619, if we flip these, is 131, so it's the opposite of 131, which is $869. That's how I mentally do it. $42,869.47 of interest. And of course, not every payment got the same amount of interest. Your early payments got more interest, and we'll finish this section in the next video.